Hello and welcome to Friday's second edition of Cracking the Cryptic, second edition because there was a crossword video earlier on by Mark, so I hope you've enjoyed that. And well, I'm sure you did. But this video is not a crossword video. The eagle-eyed amongst you will realise this is a sudoku video in which I'm going to attempt a puzzle by the American math teacher RockyRoer called A Bouquet of Complements. Or should that be a bouquet of compliments? No, a bouquet. I think it's a bouquet. It's like a flower or a bow. No, actually, how do you say bouquet? Do you say bouquet and I say bouquet? I don't know. Is this a tomato problem? I'm not sure. Anyway, this is what it is. And lots of you have been writing to us about this. I mean, I'm sure partly because it's Fog of War, and Fog of War puzzles are always tremendously popular, but also because apparently, well, we're told this is a delightful way to do maths homework. So there must be some maths. I forgot to read the instructions before I turned on the webcam. Oh, there's complements. Complements with an E spelling. A pair of two-digit numbers read from left to right, circled. Must be these. And they add up to 90. Okay. Anyway, we'll read the rules properly in a moment, but apparently this is a very, very beautiful puzzle and not too difficult, even though it's like your maths homework. And it's meant to be a lot more fun than maths homework. So we shall see. I mean, RockyRoer has been on absolute tear recently. I can think of two puzzles, at least in the last month or so, that have been absolutely superb. And one of them was utterly, utterly incredible. And I think even people like Marty Sears wrote as a comment, and the award for Break-In of the Year goes to RockyRoer. So I'm sure this will be a good puzzle, and we'll read the rules together in a moment or two's time. Now, I don't have much to tell you about today, so I'll just make a short appeal. If you do enjoy the channel, please remember to like and subscribe. The statistics do tell us that loads of people regularly watch, but they don't subscribe, and that's a shame, because if the algorithm, well, it's a shame for many reasons, but one of the reasons is that we're reliant on the algorithm to share these wonderful puzzles as widely as possible. So if you could help us to do that, we would be really grateful. Anyway, what else? I've got a birthday to do. Ella, your best friend August wrote to us and said, could we wish you a very happy 20th birthday? Well, of course we can. I know you've been watching for about 3 years, and I think you find the videos a good way of sort of relieving stress. And well, you're not the only one. I send quite a lot of people to sleep, but we do get a lot of emails from people who find this little corner of the internet quite a calm place to hang out. So thank you, Ella, for being with us. I hope you have a great birthday today. August was singing your praises, let me tell you. She is very, very grateful you're her best friend, and I hope you get some chocolate cake, and I hope, of course, it is very well iced. But that's all the news. Shall we have a go at a bouquet of compliments by RockyRoer? The rules of this one are as follows. We have got normal Sudoku rules applying, so we're going to put the digits 1 to 9 once each in every row, every column, and every 3x3 box. Dynamic fog, so entering enough correct digits in cells will reveal more of the puzzle. Standard line rules. Hang on. Oh, okay. So the wording of these rules is, it's fine for me because I know what these things are, but it's not actually explained in the rules themselves. I should have checked this before I turned on the webcam. I can explain them anyway, so it's fine. But when you see the puzzle, there will be a fuller set of rules. So, right, so there might be some Renbans in this apparently. So let's draw a Renban line. If this was a line in the puzzle, I don't know whether it's going to have, I don't know whether the colours are going to be right, but anyway, a Renban line has to contain a set of consecutive non-repeating digits in some order. So imagine this digit was a 1, this line would have to contain 2 and 3 to be a consecutive set, but they don't have to be in order, so it could be something like that. Entropic, I can't remember what colour entropic lines are meant to be. Well, let's just draw them in that. Entropic lines means you'd have to have one digit in a set of 3 adjacent cells on the line. There would have to be one low digit, a 1, 2 or a 3, one middle digit, a 4, 5 or a 6, and one high digit, a 7, 8 or a 9. But the order will be something you have to determine. Modular. So if it's a modular line, I can remember the colour. Modular lines are normally a little bit teal colour. I haven't actually really got a good way of showing that. Oh, no, this is a disaster. Let's use blue for my modular line. So a modular line has any 3 adjacent digits on a modular line. One of these has to be selected from 1, 4, 7, and the way to look at this is from your number pad. It's the vertical slice of your number pad. So one of the digits has to be a 1, 4, 7 digit, one has to be a 2, 5, 8 digit, one has to be a 3, 6, 9 digit. Sometimes the reason it's called a modular line is that each of those sets, if you look at the 1, 4, 7 set, each of the numbers 1, 4 and 7 gives a remainder of 1 when divided by 3. And then think about the 2, 5, 8 set. Each of those gives a remainder of 2 when divided by 3. Think of the 3, 6, 9 set. Each of those gives a remainder of 0 when divided by 3. So it's one from each of those modular sets has to be in 3 adjacent digits on the line. German whispers. Now that one I can do. That's a green line. So along a German whispers line, adjacent digits have to differ in value by at least 5. So if this was a 1, this would have to be a 6, 7, 8 or 9. That's how German whispers work. Region sum. Okay, so we've got a lot going on. So in a region sum line, let's say this was the region sum line, then you split the line into segments, but according to where they cut the 3 by 3 boxes. So that would be a segment, this would be a segment, and each segment has to have the same total, and you'll have to deduce the total. It just says etc. may appear. Okay, so there may be other lines as well. Standard paired cell clues such as XV or crop key may appear. Okay, so we might see an X between 2 cells. I think I can illustrate that. If there was an X between 2 cells, then the cells must sum to 10. Now I won't be able to do a V, but if there was a V between 2 cells, they would sum to 5. And if there was a black dot between 2 cells, then one digit would be double the other. And if there was a white dot between 2 cells, then those 2 digits have to be consecutive. Apologies if I'm trotting through these apace. Now there might be, there is a killer cage. Digits in a killer cage must sum to the total given in the upper right corner. Does it mean upper left corner? That's I think it means upper left corner, because that's definitely a killer cage, and there's a 24. So what we're being told there is that those 4 cells sum to 24. It doesn't say something about no digits repeating in cages, so maybe there won't be enormous cages in this puzzle. I don't know. And then we've got this complements, which is obviously in the title. So it says, a pair of 2-digit numbers read from left to right are circled. They certainly are. This pair of numbers must add to 90. Okay. Each time the fog clears, another pair will appear, each time summing to 90. So that's great. So imagine we clear fog and those 2 cells, or those are revealed. Then we'd know they sum to 90 if they look like this. So we're going to go on a journey and try and figure out what's going on. Anyway, do have a go. The way to play is to click the link under the video as usual. But now I get to play. Let's get cracking. Now I guess we're going to use the secret here, are we? I mean, the secret is something I share with only my very favourite people. But don't worry, if you're watching this video, you're definitely one of my favourite people, so I will share the secret with you. The secret of Sudoku is that any box of a Sudoku, because of the rules of Sudoku, must contain the digits 1 to 9 once each. And if you add the digits 1 to 9, you get 45. So that's the secret. We know this box sums to 45. We don't know those digits individually sum to 90. That would be ridiculous. Even if they were 9, 8, 7, and 6, they'd only add up to 30. But we do know, well, we do know those two digits sum to 10, actually. There's no other way of doing that, is there? If this pill and this, or this number, so say this was 25. No, 25 is a terrible. Say it was 26. If this was 26, then to sum to 90, this is going to have to be a 4, isn't it? Because we need the sum to end in 0. And then this will be a 6. Yeah, that's interesting. Okay, so this isn't working quite the way I thought it was. But what we're effectively learning here is that these digits sum to 10. And therefore those digits, which are sort of the tens digits, if you like, in the numbers, they must sum to 8. Because for 90, what you're getting is these two summing to 10. So that's 10 of the 90 we've already achieved. And these two are going to sum to 80 effectively. But as they're tens digits, they must sum individually to 8. So, okay, well, that means we can do now the maths of the box. Because if these sum to 8 and these sum to 10, those 4 digits altogether sum to 18. 18 and 24 is 42, and we can use the secret to extract that the value of this is 3, and I really hope that clears fog. Oh, right. Okay, so we didn't have to know that Renbans were red because it literally tells us that Renbans are red. But do we just abandon this box now? Because we know those two sum to 8, so they're either 1, 7 now or 2, 6. They can't be 3, 5 anymore. And these two sum to 10 without being 3, 7. So there's a myriad of ways of doing that. 1, 9, 2, 8, or 4, 6. All right, let's try this one then. So it's the same principle, isn't it? These digits must sum to 18. But you can do tricks with 3-cell Renbans. I don't think I know any tricks with 4-cell Renbans in terms of the mathematics of them. A 3-cell Renban, because they're consecutive digits, you just take the middle value digit and call it x. Then you know the highest value digit is x plus 1 and the lowest value digit is x minus 1. So the line must sum to 3x, which is divisible by 3, which often we've seen as very useful in sudoku. But this one is not going to it hasn't got that same principle applying to it. It might be more to do with the fact that's got to be 4 consecutive digits, because let's think about that. If these two digits were 2 and 6 to add up to the 8, how would that work? If you think about the digits 1 to 9, lay them out in front of you in your imagination, and then imagine that the 2 and the 6 are missing. Well, this Renban is meant to be 4 consecutive digits. Well, there's no sequence available. 3, 4, 5 are the digits between 2 and 6, and 7, 8, 9 on the top end are only 3 digits. So that's this is definitely not 2, 6. 1, 7 is probably okay. 2, 3, 4, 5, 6, that's fine. 3, 5. No, that could work as well. 3, or no, it couldn't actually. 3, 5 is rather pretty. Let me just talk about that. If this was 3, 5, then in theory, there is one sequence this Renban could be, and that's 6, 7, 8, 9. But that won't work, because how would we make these two digits sum to 10 if we can't use a 6, 7, 8, or 9? There's no way, because it's going to have to be 4, 6, 3, 7, 2, 8, or 1, 9. So it's not 3, 5. This is a 1, 7. So the sequence on the Renban is then, it's obviously can't involve 8 or 9 because it's got to be 4 cells. So it's from these digits that are between 1 and 9. So it's either 2, 3, 4, 5, or it's 3, 4, 5, 6. So it must involve 3, 4, and 5. Yeah, that's good enough. Well, it's good enough to get this pair, because remember this pair sum to 10, and they can't be 1, 9 or 3, 7, so they're an even pair that sum to 10, so they're either 2, 8 or 4, 6, but this line must involve a 4, so they're not 4, 6, so they are 2, 8. That takes 2 out of this. This is great. This is great. So now 9 in the box has to be there. Presumably that's going to clear more fog, and we get a German whisper down here. Okay, I can immediately tell you something about this one. These two digits are a 3-5 pair. Now, how did I know that? Well, it's because of this reason. Because adjacent digits on a German whisper have to differ in value by at least 5, ask the question, can we put 5 ever on such a line? And the answer is no, because imagine this was a 5. What would this digit be? If we went to a digit that's lower than 5, but it's got to be 5 different, we're at 0 or negative numbers. And if we go higher than 5, we're at double-digit numbers, 10 and higher. So that it just doesn't work. So we can immediately say 5 is not on this line, which means 5 is in a pill. But if 5 was in the units digits of the pill, how would we make the 10 that we know is going to be in the units digits? We'd have to put another 5 in. 5 plus 5 equals 10. So the 5 is going to be in the tens digits, which we know sum to 8. So it must be 3 and 5. Now, so, So, okay, now these two digits sum to 10, and they're not 3, 7 anymore. They're also not 2, 8, because this digit can be neither 2, 8, could be neither 2 nor 8. So, this is either a 1, 9 pair or a 4, 6 pair. I think it's probably going to be 4, 6. Right, we're going to have to talk more about the German whisper. So, we've agreed that 5 doesn't go on it. Now, that means that every digit on this German whisper can be thought of either as being below 5 or above 5. It must have one of those properties. And the crucial thing to get your head around is whatever this digit is, whether it's lower than 5 or higher than 5, let's say it's lower than 5, can this also be lower than 5? No, these digits can never be 5 different. So this digit would be higher than 5. Whoops. But then could this digit also be higher than 5? No, of course not, because these couldn't be 5 different. Now what this leads to is this weird pattern along German whispers, which means there's an oscillation in the higher T and lower T across 5. So whether this is high or low, it will have the same property as those three. Let's use, what colour should we use though? And these will be the opposite. So if indigo is higher than 5, all indigos are higher than 5. And if indigo is lower than 5, okay, all right, there's a few ways I think we can do this. One way is if we think about this pair and this pair, you can see that these digits together, those yellow digits together, will use exactly 2 digits that are lower than 5, because there'll be a 3 used in the 3-5 pair, and there'll either be a 1 or a 4 used in the 10 pair. So that means we can't use, if indigo was low, there would be too many low digits in this box. So orange must be low, which means these digits are from 1, 2, and 4. Now, we said 5 couldn't go on a German whispers line. 4 is incredibly hard to place on a German whispers line because it only has one digit that's 5 different from it, that's within the panoply of sudoku numbers, and that's the digit 9. So how could either of these be 4? If this was 4, these two would be 9. If this was 4, these two would be 9. So we can't put 4 into those, which means this is a 1-2 pair, which means this is not a 1-9 pair, so this is a 4-6 pair. And these digits are we not going to get a digit here? They're 7, 8, 9. Hang on. Oh, we are going to get some digits, because I've got a 2-8 pair here looking at this cell. So that is a 1. That's a 2. Oh, I thought that was going to clear the fog. Bobbins. Okay, there's an 8-9 pair looking at that digit, so that's cleared the fog. Good. Okay. Let's just check we can't do more sudoku-age before we move swiftly on. I'm not seeing anything. Oh, could we do whispers? No. Okay. All right. Well, we've got. Oh, right. It's got modular and it even tells us what they are. That's very convenient. Thank you, RockyRoer. So, okay. So we know that these 3 digits here contain one of each modularity. Should we do some colouring? So that can be grey, that could be lime green, that can be, running out of colours here, red. Now, what about these 3 digits then? They haven't got a grey modularity digit, have they? So that would have to be grey. And now these 3 digits haven't got a lime green modularity, so that's going to be lime green. So this line here contains 2 of the grey modularity and 2 of the lime green modularity, but only 1 of the red modularity. Okay. Don't know what to do with that, so it must be the pills thingies again. Gosh, I don't actually know how to do this. I should know how to do it. There should be something in my brain that's going, it's this, Simon, and there isn't at the moment. So let me just mull this for a second. Right, this pair of digits here are not 3, 5, so at least I can limit them. They're either 2, 6 or 1, 7. 1, 7 would be very difficult. Why do I say 1, 7 would be difficult? Well, if this is 1, 7, then I've used up 2 of the 1, 4, 7 modularity digits in this pair, which would mean this would have to be a 4, because we know 1 of each modularity at least is appearing on the modular line. So if this is 1, 7, this is 4, and that doesn't work. That's quite complicated, actually. It's quite complicated, but very pretty. So what I'm saying is, if this is 1, 7, because we need a 1, 4, or 7 at least once on this line, we'd have to make this digit a red 4. But now, what are we going to make the tens digits? If this is 1, 7, we can't use 1, 9, 3, 7, and if this is 4, we can't use 4, 6. This has to be 2, 8. But we know now from the 2, 5, 8 set, we've only got 5 left to put on this line. But there must be 2 instances of 2, 5, 8 if there's only 1 instance of 1, 4, 7, because we've got 2 lime greens and 2 greys. So there's no way to do the line. It just won't work. So this has to be 2, 6, which means that the way we're adding up to 10 is with odd digits. It's either 1, 9 or 3, 7. Okay. So the 2, 6 is definitely using 1 of 2, 5, 8 and 1 of 3, 6, 9. Yeah, got it. Okay. Oh no, I have actually got it. And I know what this is. I was about to say I can prove this digit is a 3, 6, 9 digit, but I can actually, because of this 9, get it as well. Right, so let's think this through. The point here, I think, is that these 2 digits, whatever this pair is, do include a 3, 6, 9 digit, because they're either 3, 7 or they're 1, 9. So these 2 digits include a 6, which is a 3, 6, 9 digit. These 2 digits include either 3 or 9, which means that lime green and grey can't be the 3, 6, 9 modularity, because there need to be 2 of them, and there's only 1 spare. And the 1 spare is going to go here. So this is 3 or 9, and it's not 9, so that's 3. Oh, I thought that would clear fog. Okay, maybe we can get some fog cleared down here then. 5, 3, no. Okay, 5 here. No. Oh dear. Oh, okay, that didn't work at all, did it? Maybe sudoku? Oh, this digit's, hang on, that digit's not 2 or 6 anymore. So this is a 1-7 pair in this box. This is, this could do it, right. So this being a 3 means that this is actually a 1-9 pair, and that gives us this digit. So that's 7, that's 1, yes, great. Okay. Now, 5 has to actually be in one of these two cells. So if this was 5, so 8 in this box now has to be in one of those two cells, but I don't know which one. And then we've got 4 and 7 into some order in those boxes. Oh, and there's no line down here. There's just a Kropki dot. Okay, but again, it's the same principle, isn't it? They've all been the same principle. These two have to add up to 8, and we're not using 2, 6 this time. So we're using 1, 7, and this digit can't, or sorry, we're using 1, 7 or 3, 5. This digit can't be 1 or 7. So these have to be a 3, 5 pair, and we know the order from our pencil mark. So that's 3, that's 5. We're not clearing fog there, but and the tens digits, or these two that sum to 10, are not 3, 7, and they're not 1, 9, so these are even. So we're either looking at 2, 8 or 4, 6. Now can we narrow that down? This isn't 2, so that isn't 8. Oh dear. Maybe we can't. Really? Okay. Okay, what about this pair? They add up to 10, and they're even as well, because they can't be 3, 7 or 1, 9. So these are also 2, 8 or 4, 6. That's very distressing, because that hasn't worked either. Okay, let's try this white dot then. That white dot has got to have an odd digit on it. And it can't have 1 from our pencil marking, it can't have 3, and it can't have 5. So it either has 7 or 9. If it's got 9 on it, it needs 8 on it to be consecutive with it. And if it's got 7 on it, it either needs 8 or 6, which would have to go there. Bother. I think that everything there is possible. Wow. Okay, so that's not how to do it then. Right, what we're going to do instead then is sudoku. 1 in box 8 is placed. Can we do any more magic? Where's 5 in box 5? It's got to be here. That's also placed. This can't be 7, I've just noticed. I probably should have seen that before, but I didn't. This, oh, or 9. Can't be 9. I've got a 1, 9 pair here. So this is 6 or 8. Oh, that's weird. Where's, oh, hang on, that's fine. That's absolutely fine. Where's 2 in column 5? It can't go there because this is a 2, 6 pair. It doesn't seem to be able to go in either of those cells. So we can get 2, which gives us 8, of course, because these had to add to 10. Now this digit is, it's 4, 6 or 8, but it's not 6. So that's only 4 or 8. So the 6 in the column is right at the bottom, or in the bottom domino at least, which means this digit is not 6, which of course means this digit now is not 4, because 6 and 4 are adding together, and now I've got a 6, 8 pair. This is magical. It's really weird, but that's given me a 6, 8 pair here, which means this digit is a 4, which means this digit is an 8, and now we're going to be able to do the modularity on this modular line, because we need a a 5 here to be in the same modular set as the 8, and this must be a 7 to be in the same modular set as the 4. That gives me the 7, the 1 and the 9. That's a 6 now. I'm hoping every time you put a digit into one of these puzzles, you think, oh, this is going to clear the fog, and then when it doesn't happen, you get that slither of disappointment, but only for a moment. Right, this digit is now odd because it can't be 8. So this, oh, okay, that's not very helpful, is it? Where's 2 in box 8? I've got a 2-6 pair here, so it's not there, and I've got a 2 here, so that's a 2, and that's good. So this is an 8 to add up to 10. This is a 6, so that must be a 7 rather than a 9. This is a 4, so that's a 6, just using our arithmetic. This is an 8 in the corner, and this is a 9. So this box now needs a 9, which we can place. This box also needs, oh, look at that, that's a 4, but there's no grid furniture in this box. We're going to just have to rely on our native widths and the fact that these pills add up to 90. Now what about these? 4 we can place in that box, and this is 9, and it's a 6-9 pair. Now does this box add a 6-9? I tried to write it. Bad, Simon. 15, 24, that is right. Okay, so the maths is working. We're just going to have to figure something out in this box. It's pretty okay, actually, because these 2 digits, again, they must add up to 8, and they're not 3, 5, or 2, 6, so they are 1, 7, and we know the order. Then we need 9 in the column, so that's a 9, that's a 6. These 2 digits have got to add up to 10. It looks like they have to be 2, 8 to me, which is only one way of doing. Oh, there we go, we've got another one down there. This is 4. And these are 3, 5, 6. And that's properly chocolate teapotted. We can't resolve it. 3, 5, and 6 can come out of one of each of those, so we can't resolve that yet. But we have got another pill situation. So let's try the 8 pair again. This is not 2, 6 because the top digit can be neither. So it's either 3, it's not 3, 5, the top digit can't be 3 or 5, so it's a 1, 7 pair, and we get the order straight away. So we've got 7 here, 1 here, no fog cleared. And then these 2 digits add to 10, and again, they can't be 1, 9 or 3, 7, so they're an even pair. And 2, 8 is impossible because of row 8, so it's a 4, 6, and we know the order. Great. So we go 6, 4, we get more. Oh, now these are in different boxes, so I don't know how that's going to change things, but we'll think about that in a moment. We've got to put 8 here. In this row, we've not put 3 in. These digits are now 2, 5, 9. Now, I tell you one thing that changes that we will have to consider. The pair that add up to 10 here, they could be double 5 now. In fact, they really could be double 5. If they were double 5, it would just rule out 3, 5, wouldn't it, as the... Okay, how do we do this then? It's the same principle for these 2 digits. I mean, there's no way to make these 2 add up to 20 or 0. So we are still adding to 10 here, even though these are in different boxes. So we are adding these to 8 still. Now they can't be 1, 7 because this can be neither. So they could perhaps be 2, 6 in that order. Oh, no, hang on, that doesn't work. Yeah, this digit sees 2 and 6, look. So it's not 2, 6. It's got to be 3, 5. So that's going to work with this being a 3 and this being a 5, which does our chocolate teapot. 6, 3, 5 over here. And now these add up to 10. But what have we got left in row 6? We've got 9 and 4. Well, that's going to have to be 9. That's going to have to be 4. This is going to have to be 1. And that doesn't work. Whoa, what did I do wrong there? Oh, you got me. You got me, didn't you? You got me. I didn't think of something. That's very funny. You've all been shouting at me. I deserved it. I deserved it. How could I have the thought about 2 5s, and not have the thought about 2 4s? Because you're a doofus, Simon. That's the nature of you. Doofusicity. Ah, yeah, okay. I didn't think of that, but I have now thought of it. So had I been more yes, I could have been. Yeah, I could have been more diligent, couldn't I? I think about that. That's very funny. It's really, really. It's quite embarrassing, but it is funny. Right. So I'm actually going to do this a bit more slowly in order to fully appreciate what RockyRoer has done here. These are from 4, 5, 9. That is true. But this can't be 4. And therefore, we know these two add up to 10. So this digit is 1 or 5. And it's not 1. So that tells us immediately something fishy was going on. They are double 5 now. But we can't put 9 in here because that would be 95. This would have to sum to -5. So this is 4, and that's 4. And we've got 2 secrets being summed together to get to 90. That's lovely, isn't it? That's lovely. And I feel a bit ashamed, but hopefully it provided a moment of hilarity on account of my ignorance. Oh, that's 3 in the corner. That's 3 in the spotlight, losing its religion. Now, how do we resolve everything that's going on now? We probably need some magic in row 127, which we're not going to get there. That's not resolved, I don't think. So we need maybe rat magic here. 1, 2, 6. Yes, that's better. This can't be 1 or 6, so that's 2. So 7 goes in here. 2 goes in here. 9 goes in here. 2 goes in here. 1 goes in here. 1 goes in there. This row needs a 6, so let's pop that in. This is 3, 7, 8. So that's 3. That's 7. That's 8. This column needs a 6. That's useful. So 6, 2, 2, 8. 8 into the corner. And if we haven't made a ricket, we're looking for 3 and 9, aren't we? That's lovely. What a beautiful puzzle. Yes, absolutely gorgeous. A bouquet of compliments compliments with an I from me to you, RockyRoer, for entertaining me again and for catching me out. Sorry about that. Anyway, I'm sure you all enjoyed that. That's a lovely, lovely puzzle. And let me know in the comments how you got on with it. I enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.